Hi there, tubers. Welcome back, and welcome back to my channel. And today I'll be talking about calibration. And I've had so many requests on my channel about me showing how I calibrate the decks. As you know, I work on only Revox reel-to-reel tape deck, and as a hobby. And so many people have asked me, but you know, this has been a long, long road, long journey for me. I remember when I first started this journey several years ago, I was on the forum literally every single day, you know, searching for information, looking things up, reading, reading all the posts. We talk Audio Karma, tapeheads.net. That's the one I go to the most. And you know, we have there are some really good people on that channel who really helps. They really help. If you have a question, just post it on tapehead.net. And I strongly recommend my viewers, if they want to ask me a question, they can ask me a question, yes, but if the question has to do with troubleshooting, YouTube is not the forum for that. So I strongly recommend you post your question on tapeheads.net, because there are so many people, including myself, who will answer your question. And it's good to have many people chime in, because, you know, me myself, I don't have all the answers. I'm still learning this thing. You know, we must remember these decks are over 50 years old, right? So it's a journey, right? So today I'm going to talk about the calibration process. So you work on your deck and you finish recap, or if you didn't recap, you get it working properly, and you want to calibrate the deck. There are certain things that you must have before you start the calibration. It's a must. You must have tools, and it's not a whole lot of tools either, but you must have them. Basic tools. Talk about some tweezer and some screwdrivers, right? Preferably the non-magnetic screwdrivers. Flat mouth screwdriver, and some Phillips, depending on the deck you're using. But with this one, there are a few places that I will need a Phillips, like for example on the pinch roller, if I need to take it off. And here is a set of a plastic screwdriver, and these are anti-static. I got these off of either Amazon or eBay. I forget which one I got it off of. Right? So these are tools that you must have. And of course, you need a demagnetizer, because you should demagnetize the head before you even start the calibration. So I will go over that and show you how I do it with this TIAC demagnetizer. Test leads. You must have good test leads. I remember when I first started, I used to just have some alligator clips, and I would take some video or some picture, and I would post it on the forum and say, I'm seeing this on my oscilloscope, and the signal is going wild. You know, what could be going on? I remember this guy named Tape Tech on tapeheads.net. He's one of the core member there. And he says, man, you got to buy yourself some good leads. Buy yourself some proper leads before you start doing anything. lessons learned. So I bought leads. You can never have too much leads. You know, you can never have too many leads. Never. Leads, right? And a whole bag of connectors too to go with that. So sometimes you need to make different connection for your leads, because in my case I use the I will show it to you later on, the millivolt meter, and then I would use my fluke to verify the voltage that's going on over there, because that thing is over 50 years old. When I say that thing, I mean this piece here. That's the leader, and it's a unit that has a millivolt meter, a oscilloscope, and a signal generator built into it. But nowadays you don't have to go vintage like me. You can get, you know, good signal generator online, and millivolt meters, you know, more modern digital types. Okay, and so that covers the test leads and the tools, right? Another thing that you need to get is the service manual. You can never start a project without a service manual, and they are available online. They are available online. You can download them and print it out like I did, right? Now, the service manuals were not written for DIY people like me and you. They were written as references for their technicians, in back in the days, people who work on these tape decks, right? On the tape decks. So those guys go to, you know, training on how to work on the deck. So when they're in the shop, they would use this manual as a reference. So the manual does not take you by the hand and walk you through it, you know, step by step by step by step. Yes, there are steps in here, but rest assured, the steps are shortcuts to you know, to what's going on with the technicians, because the technicians, they already know how to do it. So the steps here is just a reference for those guys. You know, they know how to do this. So when you read through the manuals, you will find a lot of things very, very confusing. Very, very confusing. You know, I always say calibration is not hard. At first I thought it was hard, but after I did a few, it's not hard, it's just confusing, right? And one of the most confusing thing is when they talk about, I just couldn't get this wrapped around my head, reference level and operating level, because they use those terms interchangeable, and I couldn't understand, you know, what's what, you know, the reference level. Then I read and I get to understand what the reference level is, right, on the tape, and the operating level. So you can pick any operating level you like, because, like, for example, this Revox here, the operating level is 0.775 volts, right? If I were to look at my studio, the regular operating level is 1.23 volts, or plus 4 dB. And those are the pro decks. So these are the consumer decks. So they are much lower dB values than these. So they are calibrated at much lower dB. Right. So I just couldn't get my head around it, you know, because so many people had different views on it. So anyway, So that's for the manual. You must get a manual. Read it and make notes, because I go as so far as to take pages out of this manual and print them out. So when I'm calibrating, I just have these few sheets to use, right? So you have to have a manual. Next thing you need is the correct test equipment, right? You could have a fluke multimeter and any multimeter for that matter. It doesn't have to be a fluke. And you need a signal generator, right? And also a millivolt meter and an oscilloscope. Highly recommended. You should get those things. And another thing you need is tapes, the test tape. Now, this is the MRL test tape, right? This one is, the number for this is 21T204. This is MRL tape. And this is a 7.5 IPS calibration tape at 250 nanowebers. And that's the reference level. They also call it reference fluxivity. Fluxivity. Reference fluxivity is 250 nanowebers, right? For this tape. And you also need reel, and an empty reel, and the tape that you will be using to calibrate the deck. Now, it's highly recommended that you use the same tape you use for calibration. You should use that same tape when you make recordings, right? Because the deck is calibrated for that tape. So you wouldn't go, this tape here it's a LPR90 by recording the master, and you would not calibrate the deck with this tape. You would not calibrate the deck with this tape and then use another tape to make a recording, like a Ampex or a Maxell or something else, right? So you use the same tape, because the frequency response of this tape is different from the other ones, and the fluxivity might be different also. So you use a tape that matches your test tape and the tape you're going to use. It took me a long time to really realize that you should really do that, because I've experimented with tape where I calibrate for this tape, the recording the master, and I just use something else to make a recording, and it just sounds different. Yeah. Okay. So you need a blank tape. This one here is a blank tape. It's blank. All right. And if you have a tape that's not blank, you can also use like what they call a bulk eraser to erase the entire tape and get it back to sounding like virgin tape. Yes. So so the test equipment, I'll just show you what I use here. So I showed you this before. This is the leader. This is 70s technology, 1970s, right? So you have a signal generator, and then you have your WOW1 flutter meter here, and you have the millivolt meter. You have the millivolt meter, and then here you have the oscilloscope. And to be fair, I've never used this oscilloscope. I just turn it on and it's working, but I've never used it. So I use this oscilloscope. This is a Sencor model SC3100, and this is an analog scope. Right. It also has a multimeter built in right here. The display is right here. And of course, I have another oscilloscope. This is a digital oscilloscope by Rohde & Schwarz, and this is model HMO1002 series. And way on top is another millivolt meter. This is a audio analyzer. This one is also an audio analyzer. This one. It's an audio analyzer, and this is also an audio analyzer by Newtrick. Now, this is from 1980s, 1990s. They are not made anymore. You have to go to. I bought this off eBay from some guy in Europe, and of course, as a backup, I have a Keithley multimeter. You have to have some redundancy built in, and of course, this is a power supply. Yeah, so those are the tools I use when I'm calibrating the deck. Okay, so where do we go from here? So I've prepped it. I've prepped the deck. So I will be following the manual. So when you do it, you can also follow the manual and make reference to what I'm talking about in the video. So first thing first, you connect the output of the deck to the input of the millivolt meter over here. Right? Then the input of the deck is connected to the signal generator output. This might sound trivial, but a lot of people just want to see exactly how it's connected. I remember when in the very beginning, I did want to see it also. So I'm doing that service to you. Oh, another very, very important tool, equipment that I use is isolation transformer. They call it a variable isolation transformer and safety analyzer. And this is by Sencor. So I plug the deck into this because this protects me from getting some big old shock. So it's not a must, but highly recommended. Highly, highly recommended. So I got to let the this audio analyzer warm up for a little bit. So now I'm going to, before I do anything, I'm going to demagnetize the head. So I've turned off the these equipment. I don't want anything running while I'm doing that. Okay. So what you do is get your demagnetizer, and then you turn it on and slowly go towards the head. Not too much sudden movements. And then I'm going to just go like this, close to the head, not touching. But there's a plastic piece on it, so if it touches the head, that's just okay. It won't go metal to metal like here. So there's a plastic piece. And then I'll just go right over here and go around the entire tape path like that. Go around the pinch roll a little bit and come around like that. Okay. It's not a very long process. So here we go. And when you finish, you just take your time and just move away slowly like that. And turn off the demagnetizer. Some may say they didn't see when I cleaned the heads, but trust me, I did clean the heads yesterday. So once I finish with the demagnetizer, I just put it back in the box and put it in the storage area. So in calibration, according to the manual, you have to set these knobs at a certain position. And it's all laid out in the manual where you should set it. Right? So let's go. Turn these switches to auxiliary. They should be fully clockwise, auxiliary, auxiliary. And this should be in the stereo position. And the volume control should be at the 0 position. And tape in the monitor position. And of course, the tape should be on. So tape is not plugged in yet, so I'm going to plug it in. So now I can turn back on my audio analyzer. Okay. 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 Now you should set the audio analyzer to generate 1000 hertz coming out. So that 1000 hertz is going to come from the audio analyzer, from the signal generator right here to the input of the tape. And then I will adjust the level of the signal generator until the millivolt meter reads 0.775 volts. I usually use my fluke to verify the voltage on the millivolt meter, because sometimes it kind of drift a teeny bit, you know. Then you might ask me, why didn't you calibrate it? Well, I tried to calibrate this unit, but the calibration process calls for some things that I've never even heard of. I don't know what they look like. A search, I don't even remember what they're called. And just couldn't do it. And there is no place I could send it to get it calibrated. I remember a couple of years ago I was in Japan, and in Japan there's a equipment store, a test equipment store in Akihabara, and I went inside and I start describing this unit and asked them if they can calibrate it. Guy told me that he had never seen this one, so they, but I'm sure probably it was a young guy what I was talking to, so he probably has never seen it. But that place carries a lot of vintage stuff, so I was surprised when they said they had never seen this one, because I was thinking of taking it to Japan the next time I go and have them calibrate it. That was my thinking. Okay, I think I have waffled on long enough. So here I'm going to turn on my safety analyzer, otherwise called variable isolation transformer, and the deck is plugged into that. So this is how the back of the deck looks. Input from the signal generator, output goes to the millivolt meter. Okay. Relay kicks in and you're ready to go. It's kind of now I'm ready to go. So what's going to happen here is that I'm going to put this to 1 kilovolts, 1 kilohertz. The meter is going to be at 1 kilohertz, which it is right here, 1 kilohertz. And then I'm going to adjust the output level so that the millivolt meter reads 0.775 volts. 0.775 volts. I think, let me do something here because I want you to see this. Okay, now I'm in business. I had to go get my selfie stick. So what I was saying is that I'm going to adjust the output level. The generator is at 1 kilohertz. So I'm going to adjust the output level here so that this millivolt meter reads 0.775 volts. This is 0.8, so 0.775 volts is like very close to that. 0.775. So okay. I have to be very gentle with this. It's about there, ballpark, right? Okay, so now the on the deck meters, the VU meter on the deck should read 0 volts. I mean 0 VU, right? And it's very close to 0 VU, very close, right? So by the time I'm finished, you know, everything will be zeroed out. So that's the first step in the calibration. Got to do that bit. So the next thing I'm going to do is the VU meter calibration, right? So the audio generator should still be where it is, and then you adjust the potentiometer. That's underneath there, so that the VU meter reads 0 VU. So what I'm going to do now, I'm going to turn the deck over on its back so that I can gain access to the potentiometer underneath it. Okay, so now that I have the deck on its back, so I'm going to adjust these two pots so that the needle, remember the needle was off of the 0, so I'm going to adjust the pot so that the needle jump up to 0. I'll do the left channel first. See that? Moves right into the 0 right there. Of course, on parallax, depending on where you stand, it will look off due to parallax. But yes, be all right. Right, you see that jump up? So now the meters are at 0 VU. Perfect. 0 VU. So remember, we have 1K feeding into the deck, and we want the 0.775 on the 0.775 volts on the millivolt meter, and the deck should be at 0 VU. So we adjusted they call these the cal pots, the meter calibration pots, and you adjust it so that these are at 0 VU. which they are. Okay, so the next thing I am going to do is to adjust the overload indicator lamps. So those overload indicator lamps are right here. There's a red LED. So when the signal go up to 6 dB higher than what it is now, these LED will light up. So in order, and then there's a pot on right underneath here. There are two pots that I need to adjust. I need to adjust them so that the overload light just barely turn on, just barely comes on. So in order to do that, I have to get the deck back upright again. So let me do that now. So now I am going to adjust for 1.55 volts on the millivolt meter by varying the output level of the generator. First, I want 1.55 volts. You got to move it to the 3-volt scale. Yeah, 1.55 volts. Okay, so here we go. So when it reached to 1.55, you should see the light turn on. So the light is not on. So let me adjust it to 1.55 volts. One point five. 2, 4, 10. 1.55 is about there. And now the lights are on. So what I'm going to do, I'm going to adjust the pots. These two pots right here. This one and this one. Those are the left and right channel. So that the light just barely lights up. You will see just barely lights up. How can I do this? Okay, so we're ready. Let's see. So you're gonna see the light go out, and then I will adjust the pot until the light just barely turn on. That's kind of little finicky. Yeah, that will do. Same thing for the other one. Okay, I think that will do. Okay, so if you go back down to 2.775, Select 0, yeah, 0 VU, and if you bump this up, you're gonna see the light come on. Bump it up too. See that? Yeah. Okay. So that light is for when you're playing, when you're doing a recording. You just keep the needle away from the red. If it goes in the red, then that light will come on. That means it's overloading the circuits. Okay, so now I'm gonna adjust the record, the reproduce head azimuth, coarse adjustment. Okay, so what I have to do here is to disconnect the generator. Just plug it out, so nothing is going into the deck. And the manual says I should just have the millivolt meter connected to the left output. So I will just remove this. So it only to the left output. Oh, by the way, the oscilloscope is also connected to here, this point. So we can monitor it in both places. So I'm going to get the calibration tape, and I will be running the azimuth section of the calibration tape. That's the portion that has the 10 kilohertz signal on it. And then once the signal is coming through the deck, I will be adjusting. I will be making an adjustment to the tape head, the reproduce head. So here is the reproduce head, this one. So this is the reproduce head, this is the record head, and this is the erase head. So in adjusting the azimuth on the reproduce head, I will be adjusting this screw here. So from the factory, usually if no one had messed with the heads before, it would have a red, like a red paint, like you see here on the screw, indicating that the screw was not removed. So, and then and the record head, you see that one has been moved also. So look like someone, or due to age, the paint might just get brittle and crack and just fall off, you know. So I can't say for sure that someone had touched it before. But a good indication is that I'll show you something. If you look at the back, this is the back panel on the deck, for this deck. And if you notice, these holes have not been punched. They have not been punched. So if someone was working on the deck before, they would punch these holes to get to these pots. And that's the reason why I didn't put the back on it. I just want to leave it, you know, kind of stock. I want to leave it stock. So that's why I didn't put the back on it. So probably nobody touched it before. For sure they didn't touch it. They didn't bore this. So probably no one had adjusted those old pots before, but these are all new pots. And in my previous video, I said that many times you hear that you should measure the parts before you take them out, measure the old parts before you take them out, and use that same value on the new parts, which I did. I take out the old parts and I put the new ones in. But first I did measure the old parts, and then I adjusted these parts to those old values from the old parts that I took out. So probably that's why the VU meter got so close when I before I adjusted it, you know. So let's see the head. I won't touch the head yet until I run the calibration tape in it, and then I will see the signal on the oscilloscope and on the millivolt meter. So now I'm going to string up the MRL tape. So I should point out that when I rewind the tape, you will hear a lot of noise coming from the deck, like something is breaking. But that noise comes from the tape counter. The tape counter has to be changed, so it doesn't affect what I'm doing here, so I don't need to change it right away. But it worked, but it just noisy, so I'll have to do something about that. Okay, so if you notice on the deck now, I had to adjust the switches according to the manual again. So they want this like this. These were all the way to the right before. Now you put them to counterclockwise. Everything else remains the same. And of course, the monitor switch goes into the monitor. Goes into the monitor position, I should say. Okay.
MRL calibration tape, NAB equalization at 250 nanowebers per meter. 1 kilohertz at reference fluxivity. (500 Hz at minus 10 decibels. Set gain for azimuth and frequency response calibration.
We are searching for the 10 kilohertz section of this tape. I should point out that the manual called for 10 kilohertz, but the tape has 8 kilohertz. So we'll go with that. We have to go with the 8 kilohertz that's on the tape.
8 kilohertz. Course azimuth set. $16 kilohertz. Fine azimuth set.
So what I'm going to do now is to adjust the reproduce head, and I'm going to watch the millivoltmeter too when it gets to the highest point. That's the objective of this test.
8 kilohertz. Course azimuth set.
Okay. I don't know if you'd be able to see that, but the meter, as I adjust it, it go back and forth, and it come right up to the highest point. The oscilloscope, I tried to look at it on the oscilloscope, but it was fluctuating too much, so I just used the millivoltmeter. So now I'm going to do the fine azimuth adjustment. So reproduce head, fine azimuth adjustment. So I gotta change this around again. Another thing with calibration, it's all musical chairs, you know. Okay, so for this step, I have to switch the selector switch to mono. Selector switch to mono over here. And then connect the millivoltmeter to both channels. Okay. So we're going to use that same 8 kilohertz, and we're going to run the tape again, and then we're going to adjust that same screw and look out for the highest point that the millivoltmeter reaches. I know it's kind of hard to see on the camera. I'm trying my best to see if I can let you see it, but I can see it, no problem. I can see it. Okay, now the fine azimuth setting is coming up. So watch the millivoltmeter carefully.
Course azimuth set.
But the course is already set, so I'm waiting on the fine azimuth.
$16 kilohertz. Fine azimuth set. Frequency response calibration. 32 hertz.
It fluctuates a bit, but I could see it move up to the highest point. Okay, the scope has settled down, so I'm going to do over the coarse azimuth setting again, so you can see the movement when I adjust this the playback head.
Hertz at minus 10 decibels. The gain for azimuth and frequency response calibration.
Okay, watch it now. Watch the movement. You see that? One highest point on the oscilloscope. Okay, it's good. Highest point. Now we're going to do the
16 kilohertz. Fine azimuth.
fine azimuth setting. We're going to do the same thing. Watch the scope again. Jump in a little bit more. We want the highest point. See, getting bigger. Okay. So that's what we need. Okay. All right.
Frequency response calibration. 32 hertz.
So what I'm going to do now is to verify the setting of the fine and the coarse azimuth setting by just using the oscilloscope and the XYZ ZY function on the oscilloscope. You should get a 45-degree angle when you when I turn the reproduce head screw. All right, so here we go. See that?
8 kilohertz. Coarse azimuth set.
Coarse azimuth setting. It's really dancing right there, but that's as close as I can get it to be a straight line without the oval shape. But that's what it is.
16 kilohertz. Fine azimuth set.
Now you see the difference with the fine azimuth setting? It's just one straight line at 45 degrees. And that's what you're supposed to be getting. So this one is looking real good.
Frequency response calibration.
So what happened is that because this is a whole deck, almost 50 years old or over 50 years old. So the head, I checked the head, and the head looks okay to me, but I know it's a bit worn. Could use a new head. But that's the problem we have with these old decks. We have to just take what we get, because if I were to go on eBay and buy a head from someone, probably that head is even worse than this. You know what I mean? So we just have to use what we got and make the best of it. Okay, the next step now is to calibrate the reference level from the calibration tape. So tape it. The deck is set up just as before, but this time we're gonna adjust the pots. These two pots here. So that you get the correct levels. You must note that these two pots are located on the reproduce PC board. Before that, we were adjusting the pots on the monitor PC board. Let me show you these two pots. This is the reproduce PC board, and this is the monitor PC board. So we were adjusting these pots on the monitor PC board before, and this now is the output amplifier PC board. And then right here we have the input amplifier, the record amplifier, and the oscillator PC board. So if you have the manual, you can see these in the manual. So now I'm going to reverse the tape to the reference level section of the tape, and I will play the tape and make the adjustments. So when I make the adjustments, when I play the tape and from the reference level, when I make the adjustments, the VU meters are supposed to read 0 dB on the VU meters, and the reading on the millivolt meter should be 0.775 volts, and that's the reference level.
MRL calibration tape, NAB equalization at 250 nanowebers per meter. 1 kilohertz at reference fluxivity.
Okay, so you see right there on the VU meter, it's now at, I'm going to just turn it, you see that? That's what, put it back at 0. And on the millivolt meter, it's 0.775 volts.
Again, for azimuth and frequency response calibration.
You see the course azimuth setting. I'm doing this over because the lighting was bad. So that's the best I can get. The course azimuth.
16 kilohertz, fine azimuth set.
See that? That's how it's supposed to be. So that's, you could say that's perfect. The lighting was bad. Light was bleeding over from my window right here. So I had to come a little closer to the oscilloscope to get rid of that shade. Okay. Okay, next I am going to measure the oscillator frequency and RF voltage from the erase head over here. So I've set it up already. So you got to put the deck in the record mode to do that. Okay, so the voltage here is 31.1 volts, and let me see, the manual says it should be between 30 volts and 32 volts, so we are dead on that one. Now the frequency should be 150 kilohertz plus and minus 5 hertz. So got my fluke here. So the frequency here is 148.8 volts. I mean, not volts, 148.8 kilohertz. So I think that's very close. It says it should be between 150 plus or minus 5 hertz. So the 148.8 is well within that. So I'm just going to leave it where it is. Next, the bias strap should be measured. It says here that we should get a reading of less than 350 millivolts, and these are the test points. That's on the oscillator board. I mean, the record amplifier board. So I've set it up at the test point. And I'm getting 236 millivolt. So it's well within that, less than 350 millivolts. So that's good. Let me see the other channel. This is saying 52 millivolts. Still less than 350 millivolts, so I'm just going to leave it. So if it was higher than 350 millivolts, I would have to adjust the bias strap right here. And these are very tricky because I've had to adjust them before on other decks and the thing just fall apart. So I don't want to take that chance, seeing that I'm getting less than 350 millivolts. So I will just leave it as is. So now I'm going to do the record head azimuth adjustment, and the record head is right here. So I'll be adjusting the screw on the record head to get maximum output. And in order to do that, I have to set up the millivolt meter, set it to select the 100 millivolt scale, and then select the 10 kilohertz. Then I have to put the deck in record mode, and then adjust the level of the output level of the generator so that I get 0.775 volts coming out of the deck. So I'm going to do that now. But first, before I do, I need to tell you that this is a blank tape, virgin blank tape that I'm using to make this adjustment. So this is a LPR 90 tape, recording the master tape. Okay. As you can see, look at the oscilloscope. You'll see the 45 vertical line right there. 45-degree angle on the oscilloscope. So I do not need to adjust that head much because it's there already. So I wouldn't mess with the head. So that's how you would adjust the coarse azimuth setting for the record head. So now I'm going to adjust the record head. If you look at the oscilloscope, you see that oval? So you want to get the line at a 45-degree or as close as possible you can get it. You got to turn the screw very slowly. Okay, I think that's as nice as I can get it. And that's the coarse record head adjustment. So for the fine record head adjustment, now for the record fine adjustment, what we're going to do is turn the selector switch to mono and adjust the output level so that you get 77.5 millivolts on the millivolt meter. Then you put the tape selector switch to tape, and then we're gonna record on it and then adjust the head. And like I stated before, this is what we're after: a 45-degree angle on that line on the oscilloscope, and it's right there already. So I'm gonna let well enough alone. Okay, so we're on our way. So the record head fine and coarse adjustment is complete. The next step is bias adjustment. Okay, so for the bias adjustment, we're going to be setting up the deck, set up the equipment the same way as we did before, meaning that you have the output of the deck going into the input of the millivolt meter, and we have a 10 kilohertz signal coming out of the generator into the deck, right? And then we're going to adjust the millivolt meter until we get 77.5 millivolts on it. And of course we have our blank tape on the deck already. So what I will be doing here is put the deck in record mode, and then I am going to adjust these parts on the oscillator PC board. So you have the bias fast, slow, fast, slow. So this is the left channel on top and the right channel on the bottom. So how this works is that when I put it in record mode and I start adjusting the pots, the millivolt meter should go from left to right, and I would continue adjusting it until it reaches a peak. And when it get to the peak, I still adjust it clockwise, right? Still adjust it clockwise until the needle start falling back. Well, this tape calls for an overbias of 5 dB. So from the peak where it's falling back, I would count 5 dB back. So you reach the peak and then you come back 5. And that's your overbias. And I would do it for both channels and both speeds. So the deck, this deck is a 3.5 and a 7.5 inch IPS. So okay, so setting the bias is one of the tricky things in my experience. It's not difficult, but kind of tricky. Anyway, if you remember when I set the bias strap, they were not equal, but they were both below 350 millivolts. So I went back and I adjusted the bias straps so that they are equal, still below 350 millivolts. So I don't know if that make a big difference, if they have to be equal or not. The manual doesn't say. Anyway, so what's going to happen is that you feed 10 kilohertz from this generator at 20 dBs below zero into the deck. And if you notice, this is the 3 3/4 and 7.5 speed. So we're going to adjust the bias for both speeds. So on the on the millivolt meter, what is supposed to happen is that when you put the deck in the recording mode and adjust the trim pots, that's the bias trim pots, the millivolt meter is supposed to rise up. And when it gets to a peak, it will fall back. But you continue to turn the trim pot clockwise, and the meter will drop right back. So in my case, where the tape I'm adjusting for is LPR 90 tape. That's recording the master tape. That overbias is 5 dB. So let's say the needle come up to 0 while I'm adjusting the trim pot. I still continue adjusting to clockwise until the meter drop down to 5, and that would be the overbias on this for this tape. So that's how it works. But sometimes it gets a little bit tricky. Okay, I'm gonna do the left channel. And I switch speed to the lower speed, and then I'm going to do the same thing for the 3 3/4 speed. There you go. It's kind of hard to see from where the camera is located, but and then the VU meter fluctuates a bit, so I got to just estimate. But it went up to a peak and it came back down, so I just counted 5. Just an estimate to give you put me in the ballpark. So when I do some recording, that's when I will know that this thing is set properly, because you will hear it. You'll hear if you make a good recording or not. Yes, so that's the bias setting for you. And this in the manual, it shows you exactly how to do it. So make sure you have the manual in hand when you do this thing. Next, we'll be doing the record level adjustment. Okay, so for the record level adjustment, you have to set up the deck so that you get 0.775 volts on the VU meter. So just adjust the level, output level, to 0.775 volts on the VU meter. Then we're going to be adjusting the record level on this guy, the left channel and the right channel, while the deck is in record mode. So first we have to select a 1 kilohertz, so that we have a 1 kilohertz signal going into the deck, and adjust the deck so that, adjust the generator so that you get 0.775 volts on the output. Then you would set the monitor selector switch to tape. So what we're going to do now, once we have the deck in record mode, we are going to adjust the record level pots so that we get that same reading, 0.775 volts on the millivolt meter. At the same time, the VU meter on the deck should read 0 VU, 0.75. So that's very close. But let me see if I can tweak it some more. Okay. 0.775. Okay, so now we're going to move to the other channel. Okay, about right. Let's see now. Put it back on there. Put it left, right, same. So you see, when you switch it from taped to input, the meter should not move. If it moves, it should come back the same place. This one is a little bit off, so I'm going to do this adjustment again. That's better. Okay. If you look at the millivolt meter, you'll see that it switches barely, but it comes right back where it's supposed to be. I think that's good. Yep. Okay. So the idea, once you adjust it and you move the switch from input to output, the meters are supposed to be steady. So the meters are steady. I'm shifting it. So I will have to go back and adjust the this VU meter level. So that's fine. That's no problem. Okay. The next step is to adjust the recording equalization. And to do that, we need to set up the deck just as we had before. Switch monitor, switch to input. And then we're gonna set this to 12 kilohertz. 12 kilohertz and 20 dB below 0 VU, which is about 77.5 volts, 77.5 millivolts on the output, which you can see on the millivolt meter. We already have a blank tape mounted. Then we're going to be adjusting the EQ pots. Okay, so from here, what we're going to be doing, we are going to adjust the EQ fast and EQ slow, which means EQ fast is 7.5 IPS and EQ slow is 3.3 1/4 IPS. So we'll be adjusting these trim pots. So we'll adjust the trim pots and watching the millivolt meter so that the millivolt meter read as close as possible to that 77.5 millivolt that we just set up. So that's minus 20 dB below 0 dB. So that's what I'll be doing now. And the tape selection should now be in the monitor mode. When I say monitor mode, I mean the tape. You should put it in the tape mode, the reproduce mode. Okay. So I think I got it. So it's around about 19-20 dB below 0. So that should be fine. And this is what the meter looking like. Okay. Yes, tubers. Calibration is not difficult, but it's very, very confusing. So one of the things you have to have when you do this is you have to have a lot of patience, because a lot of it is there's a lot of musical chairs, meaning you have to repeat, do the same thing over. It's not right. Like you've seen there, my meter was always going like this, So you have to use your best guess. And, you must be aware that these are all old stuff, If if I know somewhere that could calibrate these decks, these instruments, I would gladly ship it off and have them calibrated. But I've made several attempts to find places that could do it, and they don't even know what I'm talking about. I talk about millivolt meter. I have this part number, this model number, leader so and so to calibrate. Can you do it? No, I don't. I've never seen that before. It's just, yeah. So we have to just take what we get, and I tell you, just try to share knowledge with each other. Like I said, this procedure was not meant to be a tutorial on how to calibrate the deck. I'm just merely sharing my experience, how I do it. And I take time doing it. And you'll notice that if I were to do this full time, I would starve. I couldn't feed myself, because it takes so long to do this thing, because if the thing is off a little bit, I got to figure out why is it off, and I'm there trying to do everything to get it just spot on. But there you go, that's musical chairs again, because the instrument itself is not 100%. And that's why you see I use the fluke to verify my voltages, and my frequencies in most cases, right? So it reached to a point where I have a marker where like the 0.775 volts supposed to be. So I have it, marked. So if once the needle hit that, then I know it's there, even though the scale is a little bit off, but because I verify it with this, I know where that offset is, right? And another thing, again, the bias setting is also very, very tedious, because sometimes you'd be adjusting the pots and the pots just bottom out and just won't move, so you got to be aware of all that. You could have too much signal going in, or there could be a lot of reasons why. So if you run into problem while doing this calibration, remember, post your questions on tapehead.net. A lot of people are there that will help. Just good people, they will help you. Don't be shy. And don't be afraid to ask the same question if you're not sure. Like, the manual could also be wrong, because in doing a step this evening, I find out that the manual calls for, it says you should put the millivolt meter on the 100 millivolt range, and you should adjust it until you get 0.775 volts, and that's not true. Where is it? What section is it? Let me see which I wanna bring this to your attention so you know which section to look out for this mistake in the manual. Oh, here, section 6.4.14. Right here. All right. It tells you connect the output of the millivolt meter to the output of the deck. Select the 100 millivolt range. Connect the generator to auxiliary input. Select 10 kilohertz on the generator. Load with tape, and of course, then it says adjust generator level to obtain a reading of 0.775 volts. That's wrong. It should be 77.5 millivolts. That's about 20 dB down. So the manual is there for reference, and like I said, the manuals were not written for DIY people like us 50 years later. You know what I mean? They were written for the technician of the day, and those guys would go to their manufacturer for training on how to service these decks. So the manuals are just references for them. It's not meant to step by step how to do this thing. Because when I first got into this hobby, I was looking for a step by step, and it doesn't exist. They have steps, yes, but rest assured, a lot of things are missing from those steps, and a seasoned technician would know what to do. But DIY newbies, we couldn't tell. We couldn't tell what to do. So from here, what I'm going to do next, I'm going to test out the tape. I'm going to record on it, and I'm going to see how it sounds. I already played the tape for you, and the tape that I played were those music are from YouTube library. So I don't have anything that I could record that you could listen to while I do it. I'll just have to do it on my own, because YouTube will always strike me out, and I've been struck out a few times. So I'll just abide by the rule and just play YouTube music whenever I can. All right. What else? Any comments you can just leave in the bottom of the in the comment section. I know this was a long video, and I say, like I say, I just take my time going through stuff, and I take my, just repeating myself all the time, and that's how I work. I just feel comfortable like that. Initially, I told my viewers that I don't feel comfortable working and making a video. Yes, I could do it, but the editing part of the video, that's another nightmare. I don't want to go down that rabbit hole. I find myself doing it a few times, and it takes a long time, So I guess I'll improve over time. It takes time. But that's it for now. I hope you enjoyed this long-winded video, and I'm sure that you might see something that I miss. I'm not an expert on this. I am a DIY hobbyist on this thing, but any mistake I make, rest assured that when I go back over the deck, because I'm continuously checking the deck after all this, I will find those mistakes and correct them. Even in the calibration process, if I make a recording now and it doesn't sound good, then I know that I'd have to go back and do the bias over and do the EQ over and all that stuff, right? I just take you through the process of how it's done, right? Then again, the instrument is iffy at best, so we just have to use what we got, because you cannot go out and buy these analog device anymore. You might ask me why I use the analog as opposed to a digital meter, because the analog, when you look at, for example, when you look at the millivolt meter, you can actually see movement. You know what I mean? You can actually see it moving and tell you that, hey, look, the signal is no good or the signal is good. You know what I mean? And in most cases, it will be steady. You know, while the digital device, like my millivolt meter, it's giving you the reading, but it's jumping around. You know, it jumps around. It doesn't like I couldn't use this to adjust the bias, because when you go up to that peak, this thing ain't gonna just stay steady at the peak and come back like how you would observe it on the analog meter. No, it doesn't work that way. Okay, so thank you for watching again, and I hope to see you next time. Take care. Bye.